Mastering Infrastructure with Terragrunt, a comprehensive guide. This podcast is brought to you by Business Compass LLC. We are an Amazon Web Services advanced consulting partner. We build and migrate workloads to Amazon Cloud. Our website is businesscompassllc.com. Our phone number is 973-638-2228. Our email address is contact@businesscompassllc.us. Overview. Managing infrastructure efficiently and effectively is paramount in the rapidly evolving world of DevOps. This podcast delves into optimizing infrastructure using Terragrunt, a popular tool that enhances Terraform's capabilities. We'll explore various aspects of Terragrunt, from its core principles to practical implementation strategies, ensuring you can leverage its full potential in production and development environments. Understanding Terraform and Terragrunt. Terraform is an open-source infrastructure as code (IAC) tool that allows you to define and provision infrastructure using a high-level configuration language. It manages infrastructure changes and ensures consistency across different environments. Terragrunt is a thin wrapper for Terraform that provides extra tools for keeping your configurations DRI. Don't repeat yourself, managing remote state and working with multiple Terraform modules. Organizing your files. A well-structured file organization is crucial for maintaining readability and scalability. Terragrunt encourages a hierarchical file structure in which each environment and application has its directory containing all necessary configurations. Example structure: /live, prod, app1, app2, dev, app1, app2. Creating a Terraform module. Terraform modules are reusable configurations that encapsulate one or more resources. A typical module might include resources for an AWS EC2 instance, security groups, and IAM roles. Example module structure: /modules, EC2 instance, main.tf, variables.tf, outputs.tf. Defining inputs for Terraform modules. Inputs allow modules to be configurable. Define variables in variables.tf file and provide default values where applicable. Example: variable instance _ type. Description equals type of the EC2 instance. Type equals string. Default equals t2.micro. Specifying outputs in Terraform modules. Outputs allow modules to pass information back to the root or other modules. Define outputs in outputs.tf file by example: output instance _ ID. Description equals ID of the EC2 instance. Value equals AWS _ instance.my _ instance.ed. Configuring the main Terragrunt file. The main Terragrunt file, terragrunt.hkel, specifies how to fetch and configure Terraform modules. It includes configurations for remote state storage and input variables. Example: Terraform. Source equals /modules/EC2 instance. Inputs equals instance _ type equals t3.medium. Setting up Terragrunt for production. In production, ensure robust configurations for security, scalability, and reliability. Use remote state storage like S3 and configure backend locking with DynamoDB. Example: remote _ state. Backend equals S3. Config equals bucket equals my Terraform state. Key equals prod/terraform.tef-state. Region equals us east1. DynamoDB _ table equals Terraform locks. Configuring Terragrunt for development. For development environments, use similar configurations but tailor them for cost-effectiveness and flexibility. Separate state files and use different naming conventions. Example: remote _ state. Backend equals S3. Config equals bucket equals my Terraform state. Key equals dev/terraform.tef-state. Region equals us east1. DynamoDB _ table equals Terraform locks. Architectural design. Design your infrastructure with scalability, fault tolerance, and security in mind. Use Terragrunt's capabilities to manage and deploy microservices, serverless architectures, and multi-region setups. Workflow of Terragrunt and Terraform. The typical workflow involves writing Terraform configurations, wrapping them with Terragrunt, and applying them using the Terragrunt apply command. This process ensures consistency and simplifies the management of multiple environments. Ensuring consistency. Version control, modular configurations, and Terragrunt's built-in functionalities achieve consistency, such as remote state locking and version pinning. Unforeseen obstacles. While Terragrunt simplifies many tasks, challenges like managing complex dependencies, debugging errors, and handling statefile conflicts can arise. Address these by thoroughly testing configurations and employing best practices in error handling. Consequences and effects. Effective use of Terragrunt leads to more organized, maintainable, and scalable infrastructure. However, improper use can result in complex configurations and potential downtime. Approach to problem solving. Adopt a systematic approach to problem solving. Identify issues, investigate root causes, implement fixes, and document solutions. Regular code reviews and automated testing can help mitigate risks. Goals and objectives. The primary goal is to optimize infrastructure management, reduce manual effort, and ensure consistency across environments. Objectives include achieving scalability, reliability, and cost efficiency. Team collaboration. Collaboration is critical to successful implementation. To facilitate smooth collaboration, use version control systems like Git, conduct regular team meetings, and ensure clear documentation. Summary and final thoughts. Terragrunt can significantly enhance your infrastructure management capabilities when used effectively with Terraform. Following best practices and maintaining a well-organized setup can achieve a robust, scalable, and maintainable infrastructure. Thank you for listening to our podcast. Please share this podcast, visit our website, and follow our social media links.